So there's been a lot of talk recently about AI and vibe coding in the add-on space. And I wanted to kind of give my take on this as a software engineer because I hear a lot of people, throwing these words around. It's pretty clear that they're not super familiar with what it actually means or what it entails. And so I wanted to give a small demo and I wanted to show some things to sort of give my perspective on this. And so I've built two versions of the same add-on bag scanner here. We can see that it's two frames, we can move them around. They're showing some sort of content out of our bags. If we delete some items from our bags here, we can see that they both sort of updated right away. So they're seemingly doing the same type of thing here. If we turn on the FPS display, we can see that we're around 200, 220 FPS, something like that. And if we hover this little game menu, we can see that bag scanner bad is using about 70% of all the CPU we're using right now for the game, which seems very, very high. And to get a sense of that sort of impact, if we open and disable the bag scanner bad here, we'll see how our FPS changes from about 220 to let's see, 700 FPS from just that one add-on. And if we now hover here, we can see that our bag scanner good is nowhere to be seen here. So what did just happen here? And how does it relate to AI and vibe coding in add-ons? Well, the add-ons look and function identically, so for a vibe coder or an uninitiated add-on user, it might as well be the same thing. And keep in mind that most real cases aren't as extreme as this, and that many small mistakes across your add-on suite will add up. What we just saw here are two add-ons that run the exact same bag scanning logic. The only difference between these two is how they decide to call the scanning. This is the code for bag scanner bad. It runs on every frame, whereas this code for bag scanner good runs in response to relevant events. We will come back to this later in the video once we have a little bit more context on what these things mean. Before we dig in more into what went wrong, let's take a step back and look at a bigger picture. When you're playing WoW, there are essentially three systems working together. At the bottom of everything are Blizzard's servers. This is the source of truth. Who's in your group, what loot dropped, what is that boss doing, all decided server side. Your computer just receives updates. On your machine, the game engine takes those updates and turns them into what you actually see and hear. It renders the world, it plays sounds, handles your input. It also exposes an API, basically a menu of functions that add-ons are allowed to use. And then on top of all that, your add-ons. It's not a separate program, it's Lua code running inside the engine on the same thread, sharing the same frame budget, which is exactly why a badly written add-on can tank your FPS. You can think of it sort of like a restaurant. Blizzard servers are kind of like the supplier. They provide all the ingredients, or well, data. The game engine is sort of like the kitchen. It prepares what it received from the servers and it exposes it via the API layer, kind of like a menu. Add-ons are kind of like the customer. They can order what they want, but only from the menu. So, now that we understand the layers, let's talk about the actual difference we saw earlier. The two ways your add-on can get information from the engine. The first way is polling. Imagine walking up to the kitchen every 2 seconds and asking, is my food ready yet? Is my food ready yet? Is my food ready yet? That's what OnUpdate does. Every single frame, your add-on runs its code, whether there's anything new or not. The second way is events. You sit at your table and play with your phone. When the food is ready, the waiter brings it to you. Your add-on just says, let me know when something changes, and the engine does exactly that. And here's what that actually looks like per frame. OnUpdate fires every single frame. That's your code running 100 or more times per second doing nothing useful. Events only fire when something actually happens. All those empty frames, zero cost. Besides the limitation we've seen so far, there's another important thing to keep in mind. The game engine is written in C++. It's fast, powerful, and has full control over your hardware. Kind of like a road bike. No limits, but you need to know what you're doing. Add-ons are written in Lua, a much simpler and safer language. It's kind of like a kid's bike with training wheels. You can't really hurt yourself, but you're also not going to win any races. So the takeaway is simple. Do as little work as possible inside your add-on and let the engine handle the heavy lifting wherever you can. So why does this actually matter? Let's talk about frame budgets. If you're running at 60 FPS, every frame has to be done in 16.7 milliseconds. That's not a lot of time, and everything has to fit in there. The engine needs to render the world, handle physics, process network data, and then your add-ons get whatever time is left. If your add-on takes too long, the frame can't finish in time. The engine doesn't skip your add-on, it waits. It literally sits there until your Lua code is done before it draws the next frame. That's why a bad add-on doesn't just slow itself down, it slows everything down. Your FPS drops, your game stutters, and every other add-on suffers too. And remember, this is just at 60 FPS. If you're running at 144 or 240 FPS, your budget is even smaller. Every millisecond counts. Now, let's come back to where we started, because this should make a lot more sense now. On the left, Bagscanner Bad, the add-on that tanked our FPS, is calling setScript OnUpdate. That means that this function runs every single frame. Every frame, it calls scan bags. At 60 FPS, that's 60 calls per second. At 200 FPS, that's 200 calls per second. And every single one of those calls eat into your frame budget, even when absolutely nothing in your bags have changed. On the right, Bagscanner Good. Same scan bag function, same result. But instead of running every frame, it registers for two events: bag update delayed and player entering world. The engine keeps track of when bags change and only wakes your add-on up when something actually happens. Between events, zero cost. The engine is already tracking that as part of its normal operation. Your add-on just says, tell me when that happens, and does nothing until then. Same output, completely different cost. So, is AI bad for add-on development? No. AI is a tool, and like any tool, it depends on who's using it. Think of it kind of like a chainsaw. On the left, you've got someone who's never used one before. They can still cut things fast, but they have no idea what they're doing, and the results speak for themselves. On the right, a professional. Same chainsaw, but they know where to cut, how to cut, and what not to cut. The tool just makes them faster at what they already know how to do. That's the difference between vibe coding and AI-assisted development. A vibe coder takes whatever the AI gives them and ships it. It works until it doesn't. A developer who understands the fundamentals uses AI to write boilerplate, generate the scaffolding, handle the tedious parts, but they know what good code looks like, so they can tell when the AI gets it wrong. And as we've seen today, the AI can get it wrong in ways that are really hard to spot if you don't know what to look for. I don't want to gatekeep. Anyone can make add-ons, and that's a great thing. But please, develop responsibly. Your add-on runs on everyone's machine, not just yours. Now is actually an amazing time to learn. AI tools can help you understand code, explain concepts, even write your very first add-on. But here's the thing. If you never look at what it gives you, you'll never learn. It's tempting to just keep prompting until it sort of works, but if you take a step back and try to understand what the code is doing and why, you'll end up with something better for yourself and for everyone who installs it. The performance issues we looked at today are just one category of many things that can go wrong, but they're a good example of what happens when you ship code you never actually looked at. And a quick note, if this somehow reaches anyone at Blizzard, please just whitelist buffs, debuffs, and cooldowns that originate from the player. We can already track most of these, so it's just needlessly complicated. And hey, shameless plug. If you're into WoW PvE, check out mplus.run. It's a site I built for looking up current and historical PvE data about your character. Thanks for watching.